So hello guys, today in this video we are going to study about complex function theory as you all demanded for this. So we are going to discuss about this topic in this video. So let's start. Okay, first of all, what do you understand by the complex function theory or complex number or complex analysis, anything? So foremost thing that we need to understand in this is the representation part. Okay, any complex number we have all studied in class 12th also, so we already have the general idea regarding complex number. Okay, right? So this is a function f of z which is represented using u of xy, means a function comprises of variable x and y plus I v xy. V xy is also a function comprises of x and y variable. Okay, so the term which is free from I is known as real valued function, and the term with is in contact with I is also known as iota. Okay, but for short form we will consider it as I, is known as imaginary part or imaginary valued function. Okay, fine. This is the main fundamental idea that we have to understand: what is the real part, what is the imaginary part, and what is its representation. Now there are several ways to represent complex number. Fine. So there are few fundamental representations that we will need to understand, and as we go through this course topic, we will see various forms. Okay, so one is the Cartesian representation, that is the most simplest form which we already know, that is z is equal to x plus iy. Z is a complex number which comprises of x plus iy, where x is a real variable and y is a imaginary variable, because y जो है i के साथ है, i के साथ वाला जो भी चीज होगा वो इमेजिनरी होगा, और द टर्म विच इज फ्री फ्रॉम i उसको रियल कहेंगे. ठीक है, बहुत सिंपल है, इसमें कोई दिक्कत नहीं है. द सेकंड representation is polar representation. Polar representation means पोलर से ही पता होना चाहिए इसमें पक्का cos एंड साइन आएगा ही आएगा. कोई भी चीज का पोलर रिप्रेजेंटेशन में ये चीज आता है. ठीक, सो यहाँ पे हम लोगों को कुछ सब्स्टिट्यूशन लेना होगा. सो व्हाट द थिंग्स वी हैव टू सब्स्टिट्यूट? वी हैव टू सब्स्टिट्यूट x इज इक्वल टू r cos थीटा एंड y इज इक्वल टू r sin थीटा. जब x और y पता है तो हमें कैसे कॉम्प्रोमाइज करना है? z इज इक्वल टू एक्स प्लस आई वाई. बस x के जगह पे ये डालो, y के जगह पे ये डालो. ठीक, z इज इक्वल टू आर कॉस थीटा प्लस आई आर साइन थीटा. r को कॉमन ले लो, कॉस थीटा प्लस आई साइन थीटा इज इक्वल टू आर ई टू दी पावर आई थीटा. अब यहाँ पे समझने वाली बात है, यहाँ तो सबको समझ में आ गया, r कॉमन ले लिया. तो r को मैग्नीट्यूड कहते हैं और कॉस थीटा को इसका एक्सपोनेंशियल फॉर्म कहते हैं. तो दिस फॉर्म इज नोन एज एक्सपोनेंशियल फॉर्म. ठीक है, वेयर i इज द मैग्नीट्यूड. तो r कैसे निकालेंगे वो भी हमें पता है, रूट अंडर ऑफ एक्स स्क्वायर प्लस वाई स्क्वायर. व्हाट इज x एंड y? x एंड y आर द इमेजिनरी एंड रियल पार्ट ऑफ द कॉम्प्लेक्स नंबर. और जो थीटा रिप्रेजेंट कर रहा है, थीटा क्या होगा? tan इनवर्स y बाई एक्स, जहां y क्या है? उस कॉम्प्लेक्स नंबर का इमेजिनरी पार्ट और x क्या है? रियल पार्ट. फाइन, r समझ में आ गया, उसका वैल्यू कैसे निकलेगा? थीटा समझ में आ गया, कहां से निकलेगा? ये हो गया सारे फंडामेंटल. आई होप सबको इसका आइडिया होगा यहाँ तक. ठीक है, अब नेक्स्ट आता है क्यूब रूट ऑफ यूनिटी. ये कॉन्सेप्ट है जो आगे कुछ ऑब्जेक्टिव्स में काम आता है, मे बी इसका आइडिया होना चाहिए, तो इसे भी डिस्कस कर लेते हैं. व्हाट इज क्यूब रूट ऑफ यूनिटी? द सॉल्यूशन ऑफ दिस इक्वेशंस इज नोन एज क्यूब रूट ऑफ यूनिटी. ओके फाइन, ये इक्वेशन है z क्यूब इज माइनस 1 इक्वल टू 0. z इज ए कॉम्प्लेक्स नंबर, so this can be further represented, you know, a cube minus b cube can be expanded as this one. On solving this equation we have the solution. This is one equation, this is one equation. If we solve this, this can be solved as minus b root under 4 minus b plus minus root under b square minus 4ac by 2a. Using this, if we solve, I am writing the value because it's not necessary to show how we get this solution, because we have to remember these things. Okay, these are the three roots of this equation, because this is a third degree equation, so we will obtain three solutions. Right, so these things are called the roots of this equation. Okay, this is further represented as, this is known as 1, This is known as omega, I guess. Yeah, omega. And this is known as omega square. Okay. These are the representation you should know, and you should memorize these things, because we are going to need these things at the end. Okay. So omega is minus 1 by 2 plus I root 3 by 2, and omega square is omega square is minus 1 by 2 minus I root 3 by 2. So regarding 1 omega, this is equal to not square. Okay. So regarding 1 omega and omega square, there are few properties we should know. That is, what are the properties? That is, first one is that the mod of omega is equal to mod of omega square, that is always equal to 1. Fine. Second is omega to the power, if the power of this w or omega, so there are some properties of omega. So there are 4 major properties, like the magnitude of omega is equal to magnitude of omega square is equal to 1. Okay. Now the second property is omega to the power 3n is equal to 1, means any number in the multiple of 3 will be there, then the value of omega to the power that number is equal to 1. Fine. So by seeing this, we can formulate our expression is this one, the third property. Okay. That is 1 plus omega to the power n plus omega to the power 2n is equal to 3 if n is a multiple of 3. Like we have seen that if omega is raised to the power of some power, if the power is the multiple of 3, the value will be 1. So 1 plus 1 plus 1, it will be 3. But in all other cases, it will be 0. Fine. This condition summarize this one. 1 plus omega square is 0, because the power are not in multiple of 3. Okay. So this is the property related to omega. This will be majorly focused from competitive point of view. There are questions which will come using omega, and we will use the properties like this, that if something is raised to the power omega raised to the power which is multiple of 3, the value will be 1. That will help us to solve the problems. Okay. Now next comes the circular function. Okay. Circular function of complex variable. The terms that we will get after this, the results you already know. So like we know that e to the power iy, you can use x, theta, anything. Okay. E to the power ii, we can write it cos y plus I sin y. Fine. Now e to the power minus iy can be written as, I don't want to show you the derivations, but this will help you to understand and get these things easily when we will use some solve some complex problems. Okay. So this is clear. E to the power I theta is equal to cos theta plus I sin theta. On the place of theta I am using y. Okay. Right? Now if we see this, once by adding and once by subtracting, we can obtain the value of cos y and sin y. Okay. So from seeing this, we can write sin y as e to the power iy minus e to the power minus iy by 2, and cos y as e to the power iy plus e to the power minus iy by 2. And if I ask tan y is simple, sin y by cos y. Fine. So in this expression there is a small theorem you should know. It's of no use now, right? But you should know, that is Euler's theorem. What does Euler's theorem suggest is, that is cos z plus I sin z is equals to e to the power iz. Okay. This is what Euler's theorem says, because we can see that something hidden here is, okay, I will not edit this one. How this becomes this? Because there are two ways to verify it. Cos z is just substitute this one plus I of this. You will see everything will get cancelled out and sum up to this one. Okay, you can solve this if you want to verify, or the value of R is outside something of this will that we have seen previously, where like this one, see, R cos theta plus I sin theta is equal to R e to the power sin theta, where R is root of x square plus y square. Fine. So in this situation R will be root of cos square z plus sin square z, and you know cos square theta plus sin square theta is 1, so root 1 is equal to 1. So here the R is hidden, R value is 1 and e to the power I theta, in place of theta it's z. Okay, so it's verified. So this is a small Euler's theorem. If someone asks what is Eulerism, you can easily explain. Then again one theorem comes is de Moivre's theorem. My handwriting is getting worse, I don't know why. Okay, so this theorem suggests if cos theta plus I sin theta to the power n is there, then this can be represented as I theta to the power n. Hence we know the exponential operation that this can be written as I n theta, because this get multiplies in the power. So the power I n theta can be written as, because in theta we obtained n theta, so this will be further written as cos n theta plus I sin n theta. So this is de Moivre's theorem, like something to the power n, like 2, 3, 4, 5, 6, 7 something, then the simple expression we can write it as cos that power theta plus I sin to the power raised to the theta. Okay, these are the two theorems that you may be asked to solve something related to this, so you can easily solve this. Okay, now the next comes, there are a lot of topics, small topics, so we will go quickly. Okay, so not too much hard to understand. Hyperbolic function. We have seen circular functions, in which we will this expression you can use in any questions to solve. Now what is hyperbolic function? It's same as circular function, the same objective is, only the variables are changed and the meaning are changed. Okay, in this hyperbolic function we get something different like sin hx. You must have come through this term. These are hyperbolic functions. Sin hx is represented in this is e to the power minus x. Okay, you can correlate this from there. In sine we have minus and e to the power minus, and in cos we have both the same, one is plus, one is minus, and the in between there are plus. You have to correlate these things to to memorize these things when we implement. Okay, similarly cos hx is बीच में प्लस होगा, ये याद रखना है, माइनस एक्स बाई 2. फाइन. And if I ask what is tan hx, just simple sin hx by cos hx. Okay, I think I made a mistake here. Fine, sorry. There will be 2y. When we let I sin y plus I sin y, it will get 2I sin y, and the denominator it will 2i. And here also 12. Fine. This was my mistake. Let's move to the next part. So now the another topic that is very much important, like you may get questions from this too. Okay, so the topic is singularity. So if we go through the theoretical aspect, that is, what is the singularity? A point at which a function fz is not analytic is called a singular point. And what is analytic, that we are going to discuss next. Okay, fine. Okay, from example you can understand. Okay, what is the singular point or what is singularity. Like here is an example 1 by z minus 2, where z is a complex number. So this function is not defined for which point. So as we all know, because if the denominator is 0, that is undefined form. 1 by 0 is not a defined form. Okay. So if z minus 2 is equal to 0, that is z equal to 2, then the function will be not defined. So that point is called singular point, right? So the question will be asked in such a way that if there is a given function and you have to find the singular point, and what is the type of singularities. Okay. So what are the steps to find those? Okay, and what are the types of singularities we have? So the first step is this, that you have to calculate the limit for z tends to a of an fz. What is a? This is a. Okay, we have to find the limit of this function. If it exists and is finite, then z equal to a is the singular point and it's termed as removable singularity. Okay. And again, there is another singularity, that is essential singular point. If there is a limit that we have calculated and it doesn't exist, then z equal to a, that point is known as essential singular point. You will get to understand these things when we will solve an example using this. Okay, fine. Take your time and give it a read once again. Pause the video. You will get to understand it more, in a good way. So now come to the another important aspect. We have seen how to find the singularity and what type of singularity we can find if the question is given. Right? We have seen the theoretical aspect. Okay. Now the another important function is analytic function. Okay. So let's go through the definition first. A function fz which is single valued. Okay. If we solve the equation, we get only single value, and it's a unique solution, and possesses a unique derivative with respect to z at all points of region R is called analytic or regular function. This is the main thing you have to remember. Of z in that particular region. R is the region. Okay. Just try to understand from the equation. We will see the numerical implementation. Fine. So function which is a single valued and have a unique derivative, that is, it should be differentiable with respect to z at all the points of a given region. Okay, that like we have seen in differential equation, there will be given interval and we have to find whether it is differentiable or not. Okay. Again, there is an fz, a function fz, if it is analytic at each and every point of a complex plane, it's called entire function. So from this concept, the question may be asked, you will be given a function and you will be asked whether it is an analytic function, whether it's a entire function, whether it's a regular function. So if we understand this thing, only then on we can find. Okay, if the question is asked, is this analytic or not? So what we will approach? We have to find whether it's single valued or not, whether it's differentiable or not. Okay, now we will see a very important theorem. From it help we can solve all these things. Okay, so what's the name of that theorem? You may know because you have also studied something that is called Cauchy-Riemann equation. Okay, Riemann equation. It's also called CR equation in short form terms. Okay, we will use this here, not we will not write the whole thing. Fine. So let's see this equation. So I didn't take the time to record the writings of this thing. Okay, so as you can see, what is Cauchy-Riemann equation? Like, we know that the complex function can be represented at u of xy plus I v xy, and if it is differentiable at z, then this is the condition that you have to check and you have to remember. Okay, it's very confusing. We have to remember, and it's very much confusing as I am saying, because you will put minus here, plus here, x, y, you will differentiate something, because I have also done the same thing. It took me very long time to get the grip on it. So what is the equation? Let's see. The partial derivative of u with respect to x must be equal to partial differentiation of v with respect to y. This is a sign of partial derivative. Okay, you know how to do partial derivative. Like du by dx means you have to differentiate this expression keeping y constant. because you are differentiating with x. So dv by dy, you have to keep x as constant and differentiate it with respect to y. Similarly here, du by dy should be equal to minus dv by dx. Okay, you have to verify both this condition. If this satisfy, then you can say that okay, fz is differentiable at z, that we require here. Okay, the unique derivative with respect to z. Fine. And there is a theorem derivation to get this equation. We have to just memorize it. No one will ask you the derivative. Okay, you will be asked to find the derivative of fz. How you will find? You should know this only. Okay, that is minus I uy plus vy, means minus I into partial differentiation of u with respect to y. This is the notation we use. Okay, if you are differentiating partially with respect to y, you write is u small y in the bottom and plus vy, यानी means v को आप differentiate कर रहे हैं partial with respect to y. Similarly, if you want to differentiate partially using x, the expression will be this. If you want to differentiate using y, मेरे को x ज़्यादा अच्छा लगता है. So it's very simple. So minus i y जोड़ने में थोड़ा दिक्कत हो जाएगा. So remember x, ux plus ivx, simple. Differentiate u with respect to x and partial differentiate v with respect to x. Okay. So every theorem and equation have its pros and cons. Okay. So CR condition is not sufficient, because if you see, this is also a equation du by dx. Sometimes you can get it as a fraction. If we get as a fraction, there is a probability that the denominator may be 0, and something in denominator is equal to 0, then it is not defined. Okay, so there may be cases where the denominator may be 0, so CR condition is not sufficient. Okay, so you have to keep two things in mind. One, to check this CR equation, if is satisfied, good enough, and you have to check that after partially differentiating this one, du by dy or du by dx or dv by dy, each 4 terms are continuous or not. It's very simple to check the continuous. Okay, something in fraction and is equal to 0, it's not continuous, because at that point, like we have seen in the singularity, 1 by, there in singularity, no? 1 by z minus 2 is there, and it's z minus 2, and if this is equal to 0, then this is not continuous at z equal to 2, because 1 by 0 is not defined. So in such cases, we have to check this condition, CR condition and partial derivative should be continuous. These two conditions, if these two conditions satisfied, then the function is analytic. So we will be asked to check the function is analytic or not. So you have to do this: verify Cauchy-Riemann equation, see whether it is continuous or not, and solve. We will see the numerical implementation in the next video, because it will be lengthy. Okay, thank you. Now just for only knowledge purpose, like we have seen the CR condition in normal form, like only x and y. So we have known that there are polar form also. So the CR equation in polar form can be written as CR equation we know to convert them, but just for knowledge. Okay, in that we have r. Okay, 1 by r dv by, sorry, there is partial derivative with d theta, and du in term of theta should be equal to minus r dv by, sorry, I thought it should be in frame. Okay, so CR equation in polar form is this: du with respect to dr, this is u. Okay, not v. Du by dr, partial derivation should be equal to this. Okay. Now after this, there is one method that is very important from competitive point of view and also for your understanding purpose. So let's see this, what that theorem and method is. Okay, So what is this method called? It's called Miles-Thompson method. Fine. So this is a method used for a specific type of problems. Okay. So we have know how to verify whether the given function is analytic or not, singular or not, all those things. In this type of problem in which Miles-Thompson methods are used, इसमें क्या पूछा जाएगा? We know that fz is u plus u plus iv. So you have, the purpose of this method is to determine analytic function. Determine means you have to find the analytic function. You will be given u और v, या तो आपको u दिया रहेगा या तो आपको v दिया रहेगा क्वेश्चन में, आपको एनालिटिक फंक्शन फॉर्म करना होगा उसकी मदद से. फाइन. सो इन सच टाइप ऑफ क्वेश्चन आपको माइल्स-थॉम्पसन मेथड यूज करना है. सो देखते हैं कैसे करते हैं उसको स्टेप से. लेट्स सी देम. ओके, सो आई हैव ऑलरेडी रिटन इट टू सेव टाइम. सो लेट्स डिस्कस हाउ टू फाइंड fz व्हेन u या और v इज गिवन. ओके, u और v किसी में से कोई एक दिया रहेगा. u इज द रियल पार्ट, v इज द इमेजिनरी पार्ट, ये आपको पता होना चाहिए. ओके, तो पहला केस क्या अराइज होता है? व्हेन रियल पार्ट इज गिवन, रियल पार्ट इज u. उसमें आपको क्या फाइंड करना है? फर्स्ट वी हैव टू फाइंड, फर्स्ट स्टेप ux एंड uy फाइंड करना है. ux क्या है? पार्शियल डिफरेंशिएशन ऑफ u विथ रिस्पेक्ट टू x, पार्शियल डिफरेंशिएशन ऑफ u विथ रिस्पेक्ट टू y. ये दोनों आपको फाइंड करने देता है. व्हाट इज ux? कंफ्यूज नहीं होना है. वाई ux क्या होता है? du by dx. राइट. uy क्या होता है? du by dy. ठीक है, सबको समझ में आ रहा होगा, कोई दिक्कत नहीं. जब ये पता है तो हमें आगे ऑलरेडी पढ़ चुका है. वी ऑलरेडी नो दैट f dash z डेरिवेटिव ऑफ z फंक्शन इज गिवन बाय ux प्लस iy. y में बहुत डिफरेंट था, कंफ्यूज हो जाते हैं लोग, इसलिए ये वाला हमेशा याद रखना, x वाला ux प्लस ivx. ठीक. एंड वी ऑल्सो नो दिस सब्स्टिट्यूशन दैट y v से कैसे रिलेटेड है, u एंड v कैसे रिलेटेड है. फाइन. सो u y इज इक्वल टू माइनस वी एक्स. ये आपको याद रखना है, नो अदर सॉल्यूशन. ये मत पूछिए कि कैसे होगा भैया. ठीक है, दिस इज वी हैव टू रिमेंबर हाउ यू वाई इज रिलेटेड टू वी एक्स एंड हाउ यू एक्स इज रिलेटेड टू वी वाई. दैट वी विल सी इन डिफरेंट केस. ओके, तो ये सिचुएशन याद रखना है. बिकॉज हमें u पता है तो हमें v को रिप्लेस करना है एट एनी कॉस्ट इन टर्म्स ऑफ u. ओके, वी नो u, सो वी वांट vx टू रिप्लेस in term of u. Okay, so we will substitute this thing in this equation and we will get this equation. F dash z is equal to ux minus iuy. We know u, so we can find ux and uy. Once we get f dash z, then we have to do this substitution. What is the substitution? We have to put x equal to z and y equal to 0 in f dash z and integrate it with z to find f z dash. It's very simple. I am going to discuss the theoretical aspect only in the next video because it will become very much lengthy. We will see the numerical implementation of all the things we have discussed, okay, with good examples to understand the concepts. Okay, what will be the second case? जब हमें v दिया रहेगा and we don't know the u, we don't know the real part, the imagined part is given and you are asked to find the analytic function. Same case, same चीज, देखो same step है. फाइंड ux uy था, इसमें क्या होगा? फाइंड vx vy बिकॉज वी नो v ओनली. वी हैव टू ऑलवेज रिमेंबर f dash z इज इक्वल टू ux प्लस ivx. इन दिस केस वी हैव टू रिप्लेस ux बिकॉज वी नो v, so vx can be find out. We cannot obtain ux, so we will do the substitution next, that is ux is equal to vy. These two terms you have to remember at any cost. This one, sorry, and this one. Without this you cannot solve this equation. Fine. So once we know this relation between ux and vy, we will form a equation of f dash z is equal to vy plus ivx, and again the same substitution that we have done already, x equal to z, y equal to 0 in f dash z and integrated with z. Fine. So this is the whole theory in complex function analysis. Another thing is there, that is complex integration, that we will discuss after these topics, because this is the initial topics and most questions are from this topic, because those are, you know, very much, most questions are asked from this topic. Okay, and the complex integration part is, it's very much complex, and it is, you know, it's a bit of tough level. I will try to make you understand that topic also in the next video, next to next video, because next video will the numerical implementation of all the theory we have discussed, and then after that video we will cover that complex integration part. Okay, so thank you, that will be all for this video.